Okay, hello everyone. Hope you guys are all still doing well. A good number of you have been asking me questions and submitting your assignments on Google Classroom and via email, so I certainly appreciate that. So thank you for continuing to do the work and following up with the material. And I do want to mention, I think a couple of you emailed me about this. You guys were saying that you weren't able to see some equations that were in the previous assignment. So what I found is that you'll need to first download the document onto your computer, and then everything will pop up. Otherwise, I think the formatting will be messed up a little bit. I'm not sure why that is, but if you first download the document onto your computer or Chromebook, then I think you'll be able to see everything. Okay, so we are actually at the end of Unit 9, which is graphing quadratic functions. So today will be the last day we do graphing, and then we're going to move on to our very last unit next time on solving quadratic equations. So I do have a review for you guys to work on, but I will just kind of go ahead and do a few problems with you guys to make sure we're on the same page. And of course, as always, please let me know if you have any questions. Some of you are already doing that, so that's great. But if these videos are not making sense, please let us know, and we can schedule a Google Meet or Zoom Meet to make sure you don't have any more questions. Okay, so let's go ahead and get started. So first we have a true or false section. We didn't really do many of these problems, but let's go ahead and take a look. So I'll look at the first one with you guys. So all quadratic functions must have at least one x-intercept. Do you think it's true or false? Now for these type of questions, generally it might be nice to draw a picture. So let's see. So here is my axis. So then you want to ask yourself, can I draw a parabola or a quadratic function that does not have an x-intercept? All right, and I think in this case, the answer is yes. So for example, if you draw something like this, right? So here's a parabola, but this of course does not have any x-intercepts because it doesn't hit the x-axis, right? So in this case, our answer will be false. And here it says to explain your answer using reasoning, and you can just draw a picture. So in this case, it's false because here's a parabola that does not have any x-intercepts. Okay, and then the one in the middle, I won't go over in detail, but make sure you know how we can find the y-intercept, right? If it says has a y-intercept at 0,4, make sure you verify that. In particular, what value do you want to set for x to find the y-intercept? Okay, and then I'll let you guys try the last one as well. And then the second section is we're writing quadratic functions in any form with the following key features. So remember, we have three forms that we saw. We have vertex form, intercept form, and standard form. Okay, of course, each form tells you different things. So depending on what the questions are asking, one of these forms might be the easiest. So for example, let's say this one right over here, a function that has a vertex at 3, -11. Okay, so which form is the easiest? Well, in this case, I think it's vertex form, right? So we can go ahead and do y equals. Now, this is shifted to the right 3 because it's +3. So we need an x -3 here squared. And then on the outside, we're going down 11. So then we need a -11. Okay, and that's really it. Vertex form will be the easiest. If you try doing it in the other forms, then I think you'll have a much harder time. Let's see, how about this one down here, one that has a minimum. Also remember, a minimum versus maximum is when, or depends on if your parabola opens up or down, right? So in this case, in the first case, this will have a minimum. And then for the second one, if it's upside down, it's going to have a maximum. Okay, so really what I'm asking you to write is a function that has a minimum, meaning one that opens up. Okay, so here you can use any of these forms actually. So we want a parabola to open up. Maybe I'll use intercept form. So let's say I have a 2, and then I'll do x plus 3, x plus 4 or something, right? As long as your coefficient here is positive, that means our parabola is going to open up, so then that means we're going to have a minimum. Okay, so you have lots of options here. And then let's go ahead and take a look at maybe the one right below that. Okay, so now we want a y-intercept at 0, 10. Okay, so now the question is, which form should we use? Okay, in this case, there is actually one that's the easiest, and that's the standard form. Right, so remember the general form for that is ax squared plus bx plus c. And then as we saw last week, your y-intercept, if it's in standard form, it's just going to be our c value. Okay, because when we plug in 0 for x, these terms will go to 0, and you're just left with c. Okay, so, and then here we can really make up our values for a and b. Let's say I'll do, negative 1/2 x squared plus 4x. And then you want the y-intercept to be 10, so then we need a plus 10 at the end. All right, so that's the second part. And then all of the second page is just finding key features. Again, these are given in different forms: vertex form, standard form, and intercept form. And of course, you can feel free to look back at your notes to see how, if you forget how to find a key feature in a certain form. And again, I'll do a couple with you guys. So let's say I'll look at this one right over here, g of x. Okay, so I'm asked to find the vertex and the axis of symmetry. So remember, if it's in standard form, right, which is what this is, standard form, I have this magical formula, x is negative b over 2a. That gives me my axis of symmetry. So then let's go ahead and plug in our values. Here, b is negative 12. Right, so a is negative 3, b is negative 12, and c is 8. So it'll be negative 12 over 2 times negative 3. So that's really 12 over negative 6. So negative 2. Okay, and there's my axis of symmetry. And that also tells me that the x value of the vertex is negative 2. Those are always the same. How do I find the y value? Well, I can just plug it into my equation that I'm given. Minus 12 times negative 2 plus 8. And then you can just type this whole thing into your calculator. But I think I get negative 12, and then plus 24, and then plus 8. So I think I get 20. So negative 2 comma 20 is my vertex. There it is. Okay, and then let's go ahead and look at maybe this one over here, h of x. So here I'm asked to find the x-intercept and the y-intercept. Now this is an intercept form. So right away we can find our x-intercepts, right? We can just set each of these factors equal to 0. So x plus 5 equals 0. We get x equals negative 5. X minus 4 equals 0. We get x equals 4. And then make sure you write these as points. So negative 5 comma 0 and 4 comma 0. And then how do we find the y-intercept? Well, that's always the same thing, right? You want to set the x value equal to 0. So then I get y is equal to 3 times 0 plus 5, 0 minus 4. So that's 3 times 5 times negative 4. I think that's going to be negative 60. And there it is, my y-intercept. Okay, so let's go ahead and look at the one down here. Now this one we really have not done before. So let's see, we have a function that has a vertex at 3 comma negative 2, and it goes through the point 1 comma 4. What is another point on the parabola? Okay, and the hint is to draw a picture. So let's go ahead and do that. Let's first draw a picture. Here's my axis. My vertex is at 3 comma negative 2. So 1, 2, 3, negative 2 is going to be here. And it goes through the point 1 comma 4. So 1, 2, 3, 4, here it is. Okay, so here's my vertex all the way down here. Now it might be a good idea to also draw in your axis of symmetry. So where's that going to be? Well, that's going to be the line, this line that goes through my vertex. Okay, there it is. And then, so my parabola is going to look something like this. Okay, and we know that here's the point on the parabola, and we want to find another point on the parabola, right? So, well, the good news is we have the axis of symmetry, right, that comes from the vertex. So then we know, because a parabola is always going to be symmetrical, right, if this is a point on the graph, there has to be another symmetrical point right over here, right? So now the question is, how do I find where that point is? Well, so we have an x and a y. So the y value of that point will be the same thing as the one on the left, right? So we know the y value is going to be 4. Now, what's the x value? So if you look at the parabola, right, we see that here, this is really 2 units away from my vertex, right? Because my vertex has an x value of 3 comma negative 2. But this value right here is at x equals 1. So then if we go 2 units from my vertex, I will get the x value of 5. Okay, so then I'm going to have 5 comma 4 as my other point. Okay, so that one was a bit trickier, but I think if you draw a picture, then that should make things a lot easier. Okay, so let's go to the third page. So we have some graphs. Again, these we've done many times before over the past couple of weeks. So I think I'll just leave you guys to work on these. I will briefly touch on the last one, right? So this one, first of all, what form is that in? This one is in standard form, right? I don't have a c value, so I can just put plus 0. And then again, my vertex, negative b over 2a. My b in this case is negative 4. My a is a half. So then that's positive 4 over 1, which is just 4. So that gives me my x value. And then my y value I can find by plugging into the equation. So I get 1/2 4 squared minus 4 times 4. So that's 8. A half times 16 is 8. Minus 16 is negative 8. And there's my vertex. 4 comma negative 8. So let's go ahead and graph that one. 4 comma negative 8. And then again, it's always a good idea to draw in your axis of symmetry. And then once you have the vertex, we can use our key pattern, right? This one's going to open up because there's no negative sign. So normally we'll have up 1, up 3, up 5, but this one has a half. So then we're going to take half of these, right? Just like what we did before. So let's go up by 0.5 first, and then 1.5, and then 2.5 will be there and there. Okay, so just like that, there we go. All right, and then down here we have the graphs given, but we don't have the equations. So I'll try one of these with you guys. Let's say the one on the left. So let's first do the vertex form. So we have y is equal to, well, where's my vertex? My vertex is all the way up here. That's at, so v is at negative 5 comma 9. So then I know I'm gonna have x plus 5 squared, because this is 5 to the left, and then plus 9. Okay, and then I want to see which way my parabola opens. Well, opens down, so I need a negative sign in front. And then let's see, so here I'm going down 1 and down 3. So in this case, the pattern is regular. So then I don't need to put a coefficient that's different from 1. So I can just leave that as a negative 1, or I can just put a negative sign. So that's my intercept, that's my vertex form. Intercept form, I want to look for my intercepts. Here it is, and here it is. So then that's at negative 8 and negative 2. So then if I want to put it into equation, I need x plus 8 and x plus 2. And then just like before, the one above, I need a negative sign here as well because it opens down. Okay, now for standard form, this is actually a bit difficult to tell just from the graph. So here's how I will recommend to do standard form is I will actually take one of these other forms. Let's say I'll take the intercept form, that might be the easier one. And let's go ahead and distribute it out. So let's go ahead and do some multiplication and get this into standard form, right? So this is actually something we did in the last unit when we did polynomials. So here, if I want to distribute this out, I will first distribute this negative. So I have negative x minus 8, and then times x plus 2. And then here, we have to do our double distribution, right? Hopefully we still remember that. So I get negative x squared minus 2x, and then minus 8x minus 16. And then we can combine like terms. So that's negative x squared minus 10x minus 16. Okay, and there is my answer in standard form. So let's go ahead and put it back up here. Negative x squared minus 10x minus 16. Okay, so that's standard form, and then you can do something very similar for the one on the right here. This one is going to be positive, right? Positive coefficient because it opens up, so just make sure you watch out for that. Okay, and then on the last page, we have a couple more word problems, but we've also done those before, so hopefully these won't give you too much trouble either. But I'll go ahead and set one up with you guys. Maybe I'll try the second one, that one that's in standard form. So a tennis ball is thrown in the air. Its height is given by the function. Draw a graph with the key features labeled. Well, so right away I see that this is a +3. So that's going to be my y-intercept, right? Because this is in standard form. And my parabola is going to open down. So something like that will do. Where's my vertex? Well, here I will need to use my formula again. Negative b over 2a. B is 14, so negative 14 over 2 times negative 5. Negative 14 over negative 10. I think I get a fraction here. I get 1.4 as my x value. Okay, so my vertex is going to have an x of 1.4. And then for the y value, I can go ahead and plug in 1.4 into the equation. Plus 14 times 1.4 plus 3. Now this, I will just use your calculator. So let me go ahead and type that in. Plus 3, I get 12.8. So there is my y value, 12.8. Okay, and then I think we're ready to get started with the questions. What's the maximum height of the ball? After how long does it occur? Well, that's going to come from our vertex, right? So there's the vertex. Maximum height will be 12.8. That's our y value, and it's in meters. After how long does it occur? That's our x value. In this case, that's t. So t is 1.4. So 1.4 seconds. And then initial height of the ball, that's going to be my y-intercept, so 3 meters. And then lastly, h of 2. And what's the meaning? Well, h of 2, we can just go ahead and plug it into the equation. So I'll let you guys do that part. Okay, so that's pretty much it. This is a bit longer than unusual assignment, but this is the unit review, so it covers everything that we did over the past couple of weeks. But again, please go ahead and work on this. Let me know if you have any questions. I will post the answer key probably sometime on Friday. But yeah, let me know if you have any questions. I'm free to meet with you guys virtually via Zoom or Google Meet if that will help you. But other than that, have a great rest of your day, and thanks for watching.